Hey everyone, it's Justin again. We've learned a lot about systems in this unit, so the last thing to do is use this new tool in a real-world context. In this lesson, we're going to be looking at scenarios that require us to find an answer to multiple equations at the same time. When solving scenario or word problems that involve systems, the first thing that you should always do is read the problem and identify all the information that you've been given. At that point, you should be able to recognize what necessary information is missing. That missing information will be your variables. Now, use the known information and the variables to set up at least two equations. Once you have the system set up, decide which method will be best to solve it, then use that method. Once you've found a solution, reread the question being asked and see if you now know the answer. It's important to understand where the multiple equations will come from. The scenario will give enough information to describe two separate things using the same variables, and you'll have to write an equation for each thing. An easy example of this would be if somebody worked two jobs. We could calculate both their total number of hours and their total pay, and both of those calculations would be based on the variable amounts of how many hours they worked at each job. In fact, let's use that as our first example. Kayla works two jobs. She makes $30 per hour as an accountant and $12 an hour at a clothing store. She worked a total of 40 hours this week, earning $930. At which job did she work more hours? First, we need to set up the two equations, which means we need to know what our variables are. We know how much she earns at each job, how many hours she worked this week, and her total pay this week. What information are we missing that ties all of this together? Of course, we need to know how long she worked at each job. Those will be our variables, A for her hours as an accountant and C for her hours at the clothing store. We can use these variables to write two equations, one for her total number of hours and one for her total pay. How would we calculate Kayla's total hours based on her hours accounting and her hours at the clothing store? Well, that's easy. We add them together. What about her total pay? To get her total pay, we take her pay as an accountant, $30 times the number of hours, and add her pay at the clothing store, $12 an hour. Adding her pay for both jobs together will give us her total pay of $930. Now that we have our system of equations, we need to decide which method to solve it with. The equations in our system have all their pieces in the same order, so which method will be quicker? We can use any of the three methods, but the elimination method will be quickest here because the equations are already lined up appropriately. We need to create eliminating terms, so let's multiply the top equation by -30. This gives us A terms that will cancel, so we end up with an equation using only the variable C. Now we can solve for C and find out that C is 15. Now we plug that value into one of the equations. We'll use the top one since it's so simple. And when we solve, we get that A is 25. So our final solution is that A is 25 and C is 15. So we've got an answer, but what does it mean? Well, it's a good thing we defined the variables. That solution says that Kayla worked 25 hours as an accountant and 15 hours at the clothing store. But have we answered the question yet? Not quite, but almost. At which job did she work more hours? She worked more hours as an accountant. Here's a fun example. An art class is making friendship bracelets. The 10th graders work faster, each making 5 bracelets, while 9th graders make 3 each. At the end of class, a total of 77 bracelets have been made. If there are twice as many 9th graders as 10th graders, how many bracelets did the 9th graders make? First, what information do we know? We know 10th graders made 5 bracelets each, and 9th graders made 3. The total number of bracelets made was 77, and there are twice as many 9th graders in the class. So what information are we missing? We don't know how many 9th and 10th graders are in the class. If we had that information, we could easily find out how many bracelets the 9th graders made. Now we need to use those variables to write equations. What two big ideas can we base our equations on? We can write an equation about the total number of bracelets. If we have 5 bracelets times the number of 10th graders plus the 3 bracelets for each 9th grader, we get the total of 77 bracelets. The second equation is actually really obvious once you recognize it. We can compare the amounts of 9th and 10th graders. The problem states that there are twice as many 9th graders, so the number of 9th graders is twice the number of 10th graders. Now that we have the system set up, what method will we use to solve it? Since one of the equations already has a variable isolated, the substitution method will be easiest here. We simply take the top equation and do what the bottom equation says. Substitute 2t for n, and now solve for t. Multiply 3 times 2t, combine like terms, and divide by 11. T is equal to 7. So now we can plug that into one of our equations. Let's use the bottom equation since it's simple. 2 times 7 is 14, so n equals 14. The solution to this system, then, is that n is 14 and t is 7. But what does that answer actually mean? It means that the class has 14 9th graders and 7 10th graders. Now that we have this information, how do we answer the question? How can we know how many bracelets the 9th graders made? That part's easy. There are 14 9th graders, and each one made 3 bracelets, so altogether, the 9th graders made 42 bracelets. Right now, Vicky and Brenda have a combined 56 years of experience at NASA, but when Brenda retires in 2 years, she will have 3 times as much experience as Vicky. How many more years of experience does Brenda have? What information did this give us? Vicky and Brenda's combined experience is 56 years, and in 2 years, Brenda's experience will be 3 times that of Vicky's. This isn't a whole lot of information. Can we still set up and solve the system? The first thing we should do is figure out what's missing, and that's pretty obvious. We were told a lot about their years of experience, but we were never actually told how much each one has. So then how can we set up multiple equations involving their levels of experience? The problem split the information into now and into years. So let's try writing an equation for each of those. For right now, it tells us their combined experience is 56 years. So if we add Brenda and Vicky's experience together, it equals 56. In 2 years, Brenda's experience will be 3 times as much as Vicky's. But be careful. This equation says her experience at this moment is 3 times as much, and that's not true. We need to show that in 2 years, they will both have 2 more years of experience than they do now. So what do you think is the best method to solve this system? Neither variable is isolated, so substitution would take a bit of work, and we need to manipulate the equations to line everything up if we wanted to use elimination. So graphing is probably the easiest method here. Before we can graph these, we need x's and y's, so let's turn the v's into x's and the b's into y's. Graph the top equation, which is in standard form, by plotting both intercepts and then drawing a line through them. And we graph the second line, which is in point slope form, by plotting the point -2, -2, then drawing a line through it that rises 3 and runs 1. If we zoom in on that point where they intersect, we see that the lines cross at the point 1343. Don't forget, we had changed our variables in order to graph, so the x is actually v and the y is actually b. Our solution means that right now, Vicky has 13 years of experience and Brenda has 43. First, does this fit what the problem told us? If we add 13 and 43, we get a total of 56. And if we add 2 years to each, 45 is 3 times 15, so this solution matches the problem. All we have to do now is answer the question. How many more years of experience does Brenda have? 43 is 30 more than 13, so Brenda has 30 more years of experience. In the real world, there are lots of situations and puzzling scenarios you could run into where setting up and solving a system is an easy way to get an answer. In the next video, we're going to take a look at the worst kind of algebraic puzzle, the kind with missing pieces. See you then.